Hey folks, Chuck Black here. We are doing our Quokka walkthrough and we're actually in the 11th episode of this. If you recall, last time we talked about user interface views. That's what you see over here on the right. This time we're going to talk about other types of views, such as the worker view to let us know via heartbeat that the worker is alive and potentially to provide commands to the worker, and also for receiving data via from packet captures, port scans, trace routes, etc. that we receive. So this is an alternate use of HTTP, not just for user interface, but for remote entities such as workers or even devices to communicate with the Quokka service. So in this session, we'll talk about the actual endpoints themselves. We'll talk about how we handle the data that is received and store it in the database. Should be interesting. It's a little bit complicated, so hang on to your hats. Let's get started. Okay, so let's continue our discussion of views, also known as REST APIs. Now, last walkthrough, we talked about the user interface REST APIs, and by and large, that is the major amount of REST APIs that exist in Quokka and probably in most applications. The communication between the browser or whatever application it is that's making requests for data, etc., are going to come through user interface views, and we looked at how those were set up. Today, we're going to look at these worker type views. So these are the views that are going to be really the ones that you see over here on the left-hand side, and over here in the right-hand picture, you can see that there's a worker REST APIs over here, and then there are also data coming back from workers where we get information from packet captures, extended port scans, and trace routes. So all of those types of REST APIs, that's what we are going to talk about today. Now, one other thing I do want to mention is that with respect to workers, not only do the workers run and give us data, but as I alluded to, there's going to be a couple things happening as you can follow this line here. The workers are going to do two things. Number one, they're going to send heartbeats to let Quokka server know that the worker is alive and well. That allows us to show the user interface that gives a green status for a worker that's alive and a red status for one that's not responding. But also in certain situations, these workers may request commands to be sent down to them. And if that's the case, then the heartbeat reply will come back with commands to be executed. But let's take a look at the code that actually implements this stuff. So it occurred to me as I was saying that last bit that perhaps you would appreciate being able to see the result of these views in action. And so what I'm going to do is just run through the process of starting up Quokka and getting everything set up so that we can see what the end result is. Okay, so we can see we have Quokka up and running. It's beginning to go and monitor these guys, find out if they're available. What we're talking about though is workers. And so let me get rid of this and let's look at the user interface for workers and see what we see. So here we have 6 workers actually. We have some remote workers that might be running on a different laptop that I have, and then we have these ones that are running on this Ubuntu system on which I'm running. And I notice that these are all red, and that is reminding me, well, I didn't start my workers, so I need to start my workers. So let's do that. Here's actually a window where I was running the workers before, so I'm going to go ahead and start them now. So I should be able to see that they're going to be starting to come back up. Notice that they're going to be doing these heartbeats. The port scan did a heartbeat. The Traceroute did a heartbeat. I gave some information about what it is doing, what its serial number is, etc. And here you can see these three messages are an indication that I think I have it configured to be every 30 seconds or so, they're sending a heartbeat. And if I mention that to you, then perhaps a picture such as this, where you say, oh, well, there's a heartbeat going on, that will make a little bit more sense than even this other picture that I have, which is this one down here. You can see that the workers are actually sending their heartbeat. Now, I should be able to go up here and look at my worker screen, and sure enough, these three, the status is actually okay. Now, I'm not at the moment doing any packet capture, traceroute, or port scan. We'll look at that a little bit later, but I just wanted you to know at a high level what we're talking about when we're talking about communication with the workers, at least the communication in the form of heartbeats. As a quick refresher, if you'll recall in our last session, we talked about the user interface calls. And so in here, I'm actually in the user interface views. I'm looking at host views. And if I wanted to know where did the data, let's say from this host screen, come from, well, the answer is that the user interface, the browser code, called in using this URL, or this portion of the URL, UI/hosts, and then we just returned all of the hosts that we got from the database, and that includes status information, etc. All the stuff that you see here is included in the information that we send back. That is what our host view looks like. Now, when we talk about worker views, there's a couple of things that we're going to be talking about. One is the completely non-user interface side, which is going to be heartbeat related, and I'll get into the other stuff above this in just a second. But there also is, remember there's this screen here where I'm looking at my workers, and I'm getting something very similar to what we looked at with the hosts, where I have a bunch of information about it, as including status. And so where does that come from? In case you're interested, that is going to come, I didn't have a good spot for it. I probably could make a user interface worker views, but I just threw it here in miscellaneous views. For right now, you can see I have a couple of worker endpoints. This one is UI workers. You see that looks very similar to UI hosts that we do for hosts, and I have get all workers. As you can imagine, that's going to do a similar thing to what get all hosts does, except it's doing it for the workers. The status, what's that? Well, the status version of this is going to go down, and if I want to find out, okay, what is my response time over time, then this is what I'm getting from that. So that is the user interface side of it, and we're not going to go into that, but I just wanted you to be aware that there is a user interface side. This is in the UI portion. There's a user interface side to worker stuff. But what we're talking about is really going to be this type stuff. This is going to be where data comes in from a packet capture or from an extended port scan or a trace route, or this thing that we were glancing at briefly, this worker views. This is where a worker is going to communicate with us to let us know that it's okay. And that is what you see here in this picture, where the actual device is going to be sending HTTP requests out to the Quokka server, and it's going to tell us that it's okay. That is a heartbeat message, as you can see here. So let's look at the heartbeat. You might say, well, what's this register? It's something that's not really implemented. This is what I put in here for the situation where you want to have some level of security so that you don't have rogue devices connecting to you, and this registration process would involve some authentication. It would involve the serial number. And so that is something that is a future thing that could be added. I just put it in here because that's kind of how we tend to implement these things. But the important thing that we're talking about today is going to be this heartbeat. So this is my heartbeat. This is the endpoint. This is what the worker is going to do. It's going to send an HTTP request to worker/heartbeat, and it will be a post. And so we are going to receive this information that is going to be included with this heartbeat. So here we see that there is a post that's going to be happening. Now, a couple of things to be aware of. It is a post. I'm not checking to see what the method is because I know that it's only going to be a post, so I don't have to do that. There are no parameters that are passed along with it. I'm getting this heartbeat information from the device, the worker type entity that is sending us the information. And the way that we do this is we use this request, and I mentioned this last time, but this is the library or the package that we are using. We are using the request library from Flask. This allows us to, for free, call this getJSON method and access this data, this heartbeat information. So this is something that I have defined. The device is going to be sending me this JSON data, and I'm able to retrieve it by just doing request.getJSON. This is standard Flask right here, and I'm going to be pointing to it via this heartbeat info. And I'm going to say heartbeat info. If there isn't one, then I'm going to say, there's a problem, so I'm not going to accept this. And here, if it doesn't include the serial number, then I'm also going to reject it. So these are some checks that I do to make sure that the data that's being sent to me by the worker is including the information that I need it to have. From the serial number, what I'm going to do is I'm going to find the worker in the database. I'm not going to go into great detail here, but I'm going to do Control B. Here's my get worker. It's in this API module that is part of, as you can see, Quokka models. It is my interface in front of the database code. And what I'm going to do is I'm going to use the serial number. In my case, I'm not having it send me the worker ID. I'm having it send the serial number, and I'm going to attempt to find it in the database. And we're going to go into this at a later point in time. This is my database query. I'm going to be searching for the information. This is my search. I'm going to say my search worker type, search on the host if there's a host, search on the serial number if there's a serial number. In our situation, there is a serial number. So that is what we're going to do, and we're going to return this particular worker. So the first thing that we've done is we've gotten our worker. Now that we have if we don't have the worker, then we're going to return and say we know nothing about this worker. But if we are able to continue because we found the worker in the database, what are we going to do? We're going to take this worker entity that we got back from getWorker, which is a dictionary, and we're going to set availability to true because we just heard from it, right? This is the heartbeat. We got a heartbeat, so the availability is true. I'm going to set the last heard value. What is that? If we look back at our worker screen, I'll go here to the workers. There's going to be, this probably should be last heard instead of last checked in my user interface, but this is telling me that, okay, my last checked time is at 9:51 is the last time I heard from them. You can see up here the time on February the 3rd is 9:52, so I'm getting this data reasonably quickly. So that is that information. I'm setting worker last heard. Now I'm hoping to get response time back from the workers, so that my workers that I've created are actually getting evaluating response time of the previous request, and sending that to us. So I'm able to have that nice graph of response time. I'm able to get the CPU and memory utilization. And if there's an uptime, then I'm able to specify here in my worker the uptime as well. So once I have modified worker, then what I can do is a couple of things. I'm going to record worker status. That is going to print, or it's going to write data to the database with the information such as response time, CPU, memory, etc. So that when I do want to look at one of my workers and I click on this, I have this data in the database. That's what that is doing. The next thing I'm going to do is I'm going to set my worker. So this is really doing the same thing. This one up here is setting the worker status, but I call it record because we do multiple timestamp entries in the database. We'll see this when we get to the database discussion. I set the worker because there is one worker object in the database, so I'm updating it. What am I updating it with? Well, some of the things that I store in the worker are going to be the availability and the last heard. And it occurs to me you might want to know, okay, what is this worker? I'm not going to look at, well, yeah, I am. I'm going to go down here and say set worker. Let me dive down. This is probably the easiest way to do this. What I'm going to be doing is I'm going to take this dictionary item that I got and I'm going to find it in the database. So I'm going to look up this worker in the database. This is my query. I'm not going into SQL Alchemy right now, but this is my query to get it. If I don't find it, I'm going to create it. But if I do find it, I'm going to update all of these items if I have them in the dictionary that I got. So the dictionary that I got is worker, and I'm going to update if I have it, IP address, serial number, uptime, availability, response time. Remember, these are just one instance. This is not the time series data. It's just my one instance of worker. Last heard, CPU and memory. So let's look at worker just so you have a better idea. I'm going to go down to the class here. Now this is SQL Alchemy stuff. I'm inheriting from db.model. If you don't understand what that is, don't worry about it. Just try to kind of understand this at a very high level. This is my worker class, which is defining the actual table that is in the SQL Alchemy database. And as I said, I'll be going through this later on when we talk about doing the database and SQL Alchemy stuff. But all of these things that were fields in my dictionary are actually going to turn out to be columns in the database. So this is my strict, pretty flat translation from the dictionary into what I'm storing in the database. This, of course, is just the definition of the data. So you can see I have all of this stuff defined for my worker. And that's what we're talking about. And when I go to my APIs and I say set worker, I'm going to basically set my worker object that I got back when I did this query. I'm setting these values. And now when I do a commit, what SQL Alchemy is going to do is it's going to commit that data to the database. That's all I have to do in order to write stuff to the database. There's no SQL code. There's no really fancy handshaking or anything. SQL Alchemy takes care of that just for me. And that is the main portion of the heartbeat of these worker views. This is what I'm doing. And I will print out, I received a heartbeat from the name of the device, and I will print out that, and you'll see that in my log. Now the last thing that I'm going to point out, and I'm not going to go into this because we'll spend more time going in detail at the worker, but if there are commands for this particular worker, like let's say that I'm not using, in fact, let me pull up this picture here. Oops, no, it's not that picture I wanted. It's this picture I wanted. If I am using the heartbeat to get commands back from the Quokka server, then, in other words, I'm using HTTP rather than RabbitMQ, then this is what I'm going to be doing in this code here. I'm going to go look for commands for this device with this worker type, and I'm going to get all the ones that have been not delivered yet. And if I have some, then what I'm going to do is I'm going to return them with the commands. And so what you will see in your workers is here you can see I'm actually using RabbitMQ, so I haven't received any commands. I believe I'm using RabbitMQ. It's possible that I'm not using RabbitMQ, but I just don't have any commands. But that's what that is all about. That's the mechanism that we have when we use HTTP for delivering commands to the remote workers. Now I mentioned that the device views, this is the views that involve a device communicating with us to give us their heartbeat, are pretty much the same as the worker views that we just looked at, where the worker was giving us their heartbeat. And if we were to look at device views, remember this is in views, device views. If we look in here, you see this register, same idea. We're not using it yet. Let's look at the heartbeat. Okay, well this looks like before it had worker/heartbeat. This one has device/heartbeat. And here I'm getting my information, the JSON heartbeat information. Instead of get worker, I'm doing a get device. Once I have the device successfully, then I'm going to set things like availability, last heard. Now for devices, I'm setting vendor, potentially model, OS, version of the software. And here's some common stuff that we do with worker: response time, CPU, memory uptime. And this looks pretty much the same as before: record device status, set device. If I was to do this, as I probably should have, here I'm going to show you the, let's see, over here is my worker heartbeat, and over here is my device heartbeat. You can see that these are going to look fairly similar one to the other. At the very end of doing all of this, I do record worker, set worker. Down here, I'm going to do record device status and set device. So record worker status, record device status. So that is what device views are all about. Let me get rid of this. I'll just put that back there. And we'll close this up because we're not looking at it. And there, that is just so that you know that is device views. And one last thing I want to make sure you're aware of, remember, these are different than UI device views. If I click on device views here, then you can see that the actual URL portion is UI/device. If I look at device views here, this is my heartbeat, and it's device/heartbeat. That's my user interface. It's going to be device views, okay? So don't get these two confused. Now you'll notice that PyCharm is actually pretty nice to us. It has shown us that one of these, the one I'm looking at right now, is device/device views, and the other one that we were looking at is UI/device views. So that keeps it straight for us, and I just want to make sure that you don't confuse the two. Now the last type of view I want to talk about in this session is this. That would be the HTTP request that gets sent by workers containing data for the task that they've been given. Here in this situation, in this picture, I'm showing that there's packet capture, that it gets sent to the REST API, but port scan information, traceroute information, that all goes through the views that are defined in our view section here. So here I have my worker views. I have capture views. This is where I'm going to be receiving the information, where I'm being told, hey, store this capture. In port scan views, I'm going to have something similar, where I have port scan store. And in traceroute views, I'm going to have something similar, where I have traceroute store. And so in this situation, I'm going to be receiving data. You see it's a post in all of these situations. And I'm going to take the JSON body and I'm eventually going to record it. Here you see I'm recording Traceroute. Here you see I'm recording port scan, and here you see I'm recording the capture. So that is what is happening when data gets sent by one of these workers to us. It's sent using HTTP, we receive it, and then we store it in the database. This record capture is the thing that gets stored in the database. And just to refresh your memory, in case you're a little bit unclear, what are we talking about? Well, it would be something like this. If I wanted to do a traceroute of this Google DNS service, then what's happening, if this is configured correctly, which it seems to be, I basically sent out a request and it was received by the worker. And here you can see actually the information that was received. We got this request. Let me see if I can keep this. Here's the request. I received this message that I need to do this traceroute. I did my traceroute. I generated the image and then I sent it. This is what I sent in HTTP data. And here you can see my response. That's an HTTP response of 200. We're probably too late, but if I was to look over here, I'm not sure I'm going to be able to find it. Let me just scan it for a minute. Okay, so I did find it. Here is that Traceroute store that I got. So this is my call to the REST API Traceroute store. If I go in here and I look at Traceroute, here's Traceroute store. So I basically got this Traceroute information. I recorded it, that is, I put it in the database, and at some later point in time, one of the UI views came along and ended up asking for that data. And as a result of asking for that data, we ended up providing it. I think that it's in here. Let me see if I can find a traceroute. So I go down here to traceroute. Here's the user interface asking for traceroute information. This is in MISC, and this is where the user interface came in and attempted to get the traceroute image that might have been stored or might not have been stored in the database. It's going to do this repetitively until it finds that it is actually there. Actually, we're looking at two things here because traceroute, you can say get, that's the thing that initiates the traceroute, and you can say a get is what is going to return the traceroute data. Sorry about that. Get is going to be from the browser saying, give me the traceroute data. Otherwise, if it's a post, then this is me initiating it, and this is the code that we go through for that. I'm not going to go through that right at the moment, but you get the general idea. And in the user interface, you can see, if I get the right user interface, then you can see this is the end result. Our user interface keeps calling get of the traceroute information for this particular request, that there's a token associated with it, and once it gets it back, then it prints it up in the user interface. Okay, this lesson was a little bit complicated, so let's try to review what we talked about. We were talking about views or REST APIs, and we had talked about UI views before. This time we talked about worker views, which is where workers, remote workers, give a heartbeat periodically to show that they're alive, and also these capture, port scan, traceroute type views for sending data from the worker to the Quokka server so that it can be stored in the database so that you can get stuff like what you see right here. In the code itself, what we were looking at was worker views. Here in worker views, you can see this is my worker heartbeat, and we looked at receiving the request from a worker type of entity and how it indicated to us that its availability was true. We set last heard and we recorded other things like CPU memory, etc. And we talked about how information was sent to us, say for a traceroute, that a request was sent to by the worker with the data that would cause us to store the information in the database. So once again, we get the JSON data, we eventually change it into traceroute information and then call into our API to record it in the database. And that is how we end up with this type of data, whether it's for traceroute or packet capture or what have you. So that is the other types of views, not the UI, but the kind of work behind the scenes type views. We did mention that device views were very similar to the worker views in the sense that they do tell us that the device is alive. Now this is, just want to be clear about this, this is for devices that are communicating to us probably remotely, like in an SD-WAN type situation where firewalls prohibit us from doing direct napalm requests down to the device, NetMiko, SSH, netconf, or whatever it might be. And so we rely on the device communicating with the Quokka server to let us know that it's okay. All right, so that's another type of view or REST API. Hopefully you have a more rounded understanding. It's not just user interface stuff, but it's also these worker views and device views, etc. Hopefully you get a better idea of how we can use REST APIs in the Quokka application.